So this is the first video of the series, and in the first video, I'll be focusing on the questions which are based on the present value and the future value formulas. So this is the question from one of your exam paper, and the A part. Let's go through the A part. A person decides to take out a pension that they will draw down in 40 years. So he will keep uh, you know, he'll keep saving some specific amount, which is 600 euros in this case, on a monthly basis for next 40 years. And after 40 years, he will withdraw the money. Now, he needs some way he would save this money, and the bank offers an interest rate of 3.6 percentage per annum. So again, it's a per annum, but the compounding is being affected the compounding has been done on monthly basis. So whenever you're going to put the value for the interest rate, because you have a value, you have a formula for the future value, which would be given in your exam paper, and the formula for the future value is the principal value, the payment. You call it payment, you call it principal value, and I believe you also call it A naught, right? According to the formula that is mentioned in your notes. So let's stick to your notes one. A naught into 1 plus I to the raised power n minus 1 divided by I. So this is the formula for the future value. Now the n are the number of the number of periods, but the number of periods in which the compounding has been done. Although like you're given with the two types of periods, there's a mention of 40 years, and then there's a mention that you're saving on monthly basis and compounding is being done on monthly basis. So whenever you plug in the values into the future value formula, you need to be very careful about the n, the value for the n. And the value of the n is basically refers to the frequency of the compounding. So your compounding is being effective on monthly basis. So you'll convert this 40 years into months, right? And if the compounding was being done on yearly basis, then your n would be 40. So here I can refer to like two different cases. So first, that the compounding is being done on monthly basis. So in that case, you will multiply 40 by 12. So in every year you have 12 months, and you total you have 40 years, and you will multiply 40 into 12 to get the value for the n, right? So the value for the n would be 480 months, right? So your n for this case would be in case of monthly compounding. In case of monthly compounding, your n would be 480. But I'm just like for intuition, for conceptual clarity, I'm referring to another the question could have been asked like the compounding is been done on yearly basis. So in that case, your n would have been 40, right? So that's the difference. And A naught is the fixed amount that you put into the bank. That is 600 euros every month. And again, your I is 3.6 percentage, but this is per annum. So let's get rid of this percentage sign first. And I told you, whenever you saw this percentage sign, that means 3.6 divided by 100. So you would automatically get 0.036. But then this rate is for per annum. So you need to convert it into the months. So to convert this into the monthly rate, oh sorry, to convert this rate into the, so this is for the I yearly and you need for the monthly. So IM would be 0.036 divided by 12. So you would get 0.003. So this is your I, this is your A naught, and this is your N. So to find the future value, to answer the first part, answer to the first part would be 600 into 1 plus 0.003 to the raised power of 480 minus 1 divided by 0.003. Be very careful when you're plugging in the values, when you're substituting the values, be very careful because you formula is given in the exam paper. So the teacher technically expect you to know all these things, to convert the per annum rate into monthly basis, to convert the year the number of periods, to find the number of periods, right? So to plug in the right values, because memorization of the formula is not the agenda, is not the goal for this preparation. The goal is to you know get to the right values. So once you solve this question, so basically you're going to get V 480 equals to almost around, if you calculate this value, you would get around 642,481.39. So that would be your answer, right? So this is the part A. Now let's move to the part B. The part B says the monthly repayments on a mortgage of 5,50,000 euros are 2,501 euros every month. Right? So be very careful about this. So I'll tell you one thing. Whenever you're solving a question on mortgages or loans, right? So in this cases, you have to use the present value formula most of the times. Most of the times, 95, 99% times you would use the present value formula, right? Because think of loan. Loan is the present value of all the repayments. So you are going to get 5,50,000 euros today, and for every month you would pay 2,501 euros into the bank. So you're getting 550 lakh of 5,50,000 from a bank, and you'll be paying 2,501 euros to the bank every month on monthly basis. But you're also going to pay the interest, because bank is not going to give money and they will tell you that you can pay it back whenever, or whatever, like however you can. So they literally, they're doing their business based on money, because banks are not providing anything else. They don't like build softwares, they don't sell anything. Their whole banking, their whole like business model revolves around the money. And interest rate, inflation and interest rate are the pillars for their business models. So interest rate is 3.6 percentage per annum. Again, it's a per annum, compounded monthly. How many years does it take to pay off the mortgage? Right? So today you're getting 5,50,000 euros, and for the rest of the months, you would pay every month 2,501 euros at interest rate of 3.6 percentage. Right? Now, in the B part, you need to find the N, right? But you won't use the future value formula. You would use the present value formula, right? To find the value for the n. And the formula for the present value, this is a naught into 1 minus 1 plus I to the raised power minus n divided by I. So this is the formula, right? So you can, your V naught is, and you need to find the n here, not anything else. Your V naught would be the present value. The present value, what you're getting today as a loan, is 5,50,000 euros. And your A naught, what you are paying on monthly basis, is 2,501 euros. And your interest rate here is 3.6 percentage. But this 3.6 percentage is for per annum, and your compounding is being done on monthly basis, right? So your I would be for the yearly basis. In the subscript, I'm using Y. That means this is for the yearly basis. That is 3.6 percentage. Let's get rid of this percentage sign, and you would basically get 0.036. And what I need, because I'm doing the compounding on monthly basis, I need IM. I stands for the rate for the month. So to get the rate for the month, I need to divide the 0.036 by 12. So I'll get 0.003. So that's the same one as we did in the part A. Now you need to plug in the values, and you will solve to find the value for the n. So let's plug in the values and see what happens. Equals to 2501, 1 minus 1 plus 0.003 to the raised power minus n. This is something we are trying to find, n. And by the way, whatever I get the value for the value for the n would be in months. So the question asks you to tell the time period in years. So you will have to convert that number of months into the number of years. And how exactly would you do that? So for example, if you got an answer of 24 months, and if I ask you to convert into years, every year we have 12 months, so I'll divide 24 by 12, so it would give me 2 years. So in 2 years I have 24 months. So whatever I get my answer here, that would be in terms of years. All right. So in the denominator, I would get 0.003. Let's solve this. So here 0.036 is getting multiplied, is getting divided. If I take it to the right side, to the left side, it will get multiplied. So if you multiply 5,50,000 with 0.003, you would get 1650 equals to 2501. 1 minus 1 plus 0.003. F, right? So this is what you get. Now 2501 is getting multiplied on the right side of the equation. If I take it to the left side, it will get divided. So on the right side, I would left with 1 point. So this is what I'll get. And here, this is a positive one. If I bring it to the left side, so it would be 16. So if you divide 1650 by 2501, you would get 0.65974 minus 1 equals to minus 1.003 minus a. So you would technically get 1.03 the raised power minus n minus into this minus 1, you would get minus 0.3426. So this minus would get cancelled out on both sides, and you're technically left with this. Now you can take the natural log on both sides. Natural log on both sides. So if you take the natural log on both sides, and I told you, if you have this number, and if you take the natural log of this one, so you would, so this is the, like, the rule for the natural log. If you apply natural log on this, you will get in this way. So if I apply the natural log on this, on this term, the power would be here. So the power would be here equals to ln of 0.34026. So you keep your n over here, and you'll take the minus log of 1.003 to the right side of the equation. Now ln minus ln 1.003 is getting multiplied on the left side. If you take it to the right side, it will get divided. So it will get divided. Now, if you do the calculation, so you will get a positive number of, like, you're getting almost like nearly around 360 as your n. If you like do this calculation on your calculator, you'll get something nearly to the 360 answer. Now, this 360 is in months, and you need to answer in years. To convert 360 months into years, what I need to do, I'll divide this number by 12, and my answer would be 30 years, right? So I'll pay this mortgage of 5,50,000 euros in next 30 years if I pay 2,501 every month at a rate of 3.6 per annum, right? So, like, this is a huge amount, and like, you can also get an instinct, you can also get an understanding how this compounding and discounting works. I'm not sure if you have ever been like into this loan thing, student loans or etc etc. This interest rate thing is like really really messy. It sometimes gets really really messy, and you can actually get the idea from these basic examples. You see, like if you invest 600 euros every month at only rate of 3.6 percentage is nothing literally. Like I gave you an example in the last session. If you invest 100 euros today, and after 1 year you will get only 103.6 euros. Like apparently this is a small thing, but if you keep doing this for next 40 years, then it's a huge amount, because compounding is in the game. Compounding is a huge game, and discounting as well. So it's a double edged sword. So if you're investing, if you're saving, you are very good. If you took a debt, then you're in a problem. So let's move to the C part. The repayments on a loan of 40,000 euros are 416 each month. Interest of 7.2 percentage per annum charged on the loan, compounded monthly. After 6 years, it is decided to pay the balance of the loan in one lump sum. What is the remaining balance of the loan after 6 years? So that's an interesting part, and I want you to be very careful about this one. I'll tell you again, it's a loan problem, and you will be dealing with the present values. So what's happened? What the case? Think of C part as a case. So what's happening here is you took a loan of 40,000 euros, and the idea was that every month you would pay 416 euros every month for until the loan is paid back. But the interest rate is very high. It's a 7.2 percentage per annum, and it's been compounded on monthly basis. So after 6 years, like you keep paying 416 euros every month, and after 6 years, you decided to pay all of your loan all at once. You want to get rid of this, you know. So what would be the remaining balance? So it's not just a question of it's not a question of algebra. It's a question of future value and present value. So what would you do? You will first calculate in 6 years, how much did you pay of this 40,000 euros of loan, right? If you keep paying 416 euros every month, how much would you pay of this total amount? And please, like, be very careful. I mean, it seems like a algebra question, but this is not an algebra question. You're paying an interest of 7.2 percentage, right? If someone naive who do not understand the present and the future value and the interest rate, he can like easily come and say, if he like kept paying 6 years, every year every month he paid 416. So 6 months 6 years means how many months? 12 72 months. So 72 months multiplied by 116, because every month he paid 416 euros, and that would be the amount that he paid. But that's not the right way to do this, because you're also paying 7.2 percentage of interest rate. This is where the difference comes into play, right? So this is not an algebra question. This is a question based on the future value and the present value. And I told you, whenever you're dealing with the future, whenever you're dealing with the mortgages and the loans, use the present value formula. And the present value formula is basically V naught equals to A naught 1 minus 1 plus I to the raised power minus n divided by I. So what I was telling you, first you need to find how much did you pay in 6 years, and how much would be left, right? You will calculate the present value for that, you know. So because you need to answer the present value after 6 years. You were standing a day, like you wake up in a day and you want to pay all of your loan. So you'll calculate the present value of all the payments that you were to make every month, right? So let's solve this question and it would be much more clear to you, right? So first I need to find my n again, my n. N is important because once I get to know my n, that would be the total, you know, I mean, in the C part, I'm going to first find how many months I would take to pay the total debt of 40,000 euros. I need to find that. It's exactly the same way I did the B part. So you just need to follow all the complete steps that you performed in the B part, and then we will see after getting know our n what would be the next step. So your V naught is 40,000 and your A naught is 416 euros every month. And your I is for the yearly basis. This seems to be 7.2%, but your compounding is being done on monthly basis, and you're saving on monthly. You're you're repaying on monthly basis. So 7.2 percentage means 0.072. And if I convert this on monthly basis, so I would get 0.006. Right? So use the present value formula. This is 40,000 equals to 416. This is like you need to follow the exact same steps as you did in the B part. And what are we going to find? We're going to find how many months would it take me to pay my loan of 40,000 euros that I took from the government or the bank. Once I know that, I can answer the C part. So that's why I'm going to find this. So 1 minus 1 plus 0.006, it would give me 1.006 to the raised power minus n. This is something that I need to find, divided by 0.006. You can, it's here, it's getting multiplied, it's getting divided. On the right side, it will get multiplied. This, I'm talking about this 0.006. If this is getting divided, if I take it to the right side, to the left side, it would get multiplied. And if I multiply it 40,000 with 0.006, I would get 240 or 16. Uh, 1 minus 1.006 to the raised power minus n. Now 416 is getting multiplied on the right side. If I take it to the left, it will get divided. So if I divide 240 by 416, I would get 0.57692. How am I getting this 0.57692? I'm dividing 240 by 416, right? So that's how I got it. So 1 minus 1.006 to the raised power minus n. So I'll have this situation here. The same steps I did in the part B. So 1 minus, I'm sure like there is no confusion in this basic steps. Like this is like literally algebra. So I'll get 1.006 to the raised power equals to 0.42308. Now, what did I do in the B part? I took the natural log on both sides. I took the natural log on both sides. And I told you about the how exactly would I find that? Minus ln 1.006 equals to ln 0.423. So this is how it would be. And n would equals to ln 0.42308 divided by minus ln 1.006. So if you do the calculation on your calculator, you would approximately get 143.77. Now these are the months. These are the months that would take to pay back 40,000 euros of loan at a rate of 7.2 percentage per annum. So this is what I got, right? So this is what I got here. So what I can do is I have already paid. I have for 6 years. 6 years means 72 months. For 72 months, every month I paid 416 euros. And after 6 years, I don't want to pay every month. I want to get rid of this loan. So whatever my loan is left, I'll pay directly. Right. So what I'll do, I would have to pay 416 uh, euros every month. And how many months do I have to do this in order to get rid with this loan? I'll have to pay it for 143 or approximately 144 months. But I've already paid for 72 months. So what I can do is I can take away, like, these are the remaining months. I'm going to find the remaining months that I need. I still need to pay 416 euros after 6 years. So how many total months I would have to pay? 144, because the nearest is the 144 months. Minus how many months did I already paid? 6 years. 6 years means 72 months. Right? So I've already paid 72 months. So the remaining are 72. So I need I got that. I am yet to pay every month for the next 72 months 416 euros, right? And I want to pay it today. I don't want to pay 416 euros every month for again 72 for the next 72 months. I want to pay it today. So I'll find the present value for this, right? And the present value formula is, again, like, you will again apply the present value formula, because you're bringing all the future values that you're going to pay for the next 72 months, you're going to pay today. So you're bringing, so you would have to discount all the values from the future from till today in order to pay the present value. And again, you would use the present value formula every month, right? 1 minus 1 plus 0.006 to the raised power 72 divided by 0.006. But this time you would find the PV, and you can, like, literally calculate this value. All right. And your value, and by the way, oh, sorry, this is like minus 72, because the formula for the V naught is actually A naught, 1 minus 1 plus I to the raised power minus n divided by I. So this is the formula, right? So A naught is 416. Your I would be same 7.2 percentage. That means 0.006. The thing that we calculated over here, right? And how many months you're going to pay? 72 months. And you need to, because you want to pay today, so you need to find the present value of all the future values that you would have been paying. So in this case, if you calculate it, because here the difficult part would be to find the value of this 1.006 to the raised power minus 72, because this is a bit difficult. I'm referring to this one. Once you know the value for this, you can like simply do the simple maths, but it's pretty much simple. I mean, I told you, take like, there are two ways to solve this. But if you're allowed calculator, you can simply do. I told you, if there's a to the power minus x, you can also write it down in this way. Like, you will just have to like, if in order to get the positive power, you will take the reciprocal, and vice versa. So you can write this down in this way. Now you can go to your calculator and you can easily calculate the value. And the value would be 1 divided by 1.53848. So you will get almost around 64998 as your answer. You can, like, simply use the calculator over here. If you take the power of 1.006 to the raised power 72, you will get 1.53848. So now you can easily find the present value. Your PV was 416. 1 minus 0.6444998 divided by 0.006. So if you do the calculation, you will get 24267.8. So this is the value that you would pay today. You would pay to get rid of your loan, right? So this is it. I hope this makes sense. And I just want to conclude with the little piece of advices in in reference to these kind of questions. When you're doing the saving, the investing problem, when the statement says about the investing or the saving problem, use the future value formula or the VN formula. And for the loan and mortgage type of questions, you would refer to the present value formula or V naught formula that would be given in your uh, you know exam or in the exam question paper. And the third, I'm just generalizing all the stuff that we learned. And for example, if you're finding the remaining balance that we just did in the C part, because in the C part I was trying to find the remaining balance, and remaining balance is not like simple balance, in these kind of questions. So let's say if you had 100 euros and you spent 60 euros, and the remaining balance would be 40, but this is not the case in this case because we are dealing with the time value of money. There's a factor of time here. So here the remaining balance doesn't means this kind of a remaining balance that I just gave an example of 100 minus 60, you would get 40 as your remaining balance. That's not how it works. So whenever you have a problem of finding remaining balance, RB means remaining balance, you would use you will calculate the present value of all your future values. This is exactly what we did in the C part. I was going to pay 416 euros every month for next 72 months. So I calculated the present value for this and I would pay this to get rid of my, loan, right? And this is it. The conversion is like pretty much clear to you. And let me check if we have any other question based on this. Uh, yeah, look at this question. Question number 3. A person invests 50,000 euros in a saving account for 10 years. If the annual interest rate is 5.2 percentage, continuously compounded, what is the total value of the investment at the end of the 10 years? Now, you just need to use a different formula here. It's a continuous compounding. And for the continuous compounding, we have like a little different formula, but it's really simple formula. Like there's nothing too hard. Again, you are going to find the future value. We're going to find the future value, but this future value would be a little different. And how it would be different? The future value when it's when the compounding is being done on the on continuous basis, your future value formula would be a naught or your principal amount. So in this case, a naught is not 50. So you're not going to use a naught. This 50,000 is your principal amount. These are like little differences. Don't get confused over here because see, a person has invested 50,000 euros all at once. Like he's not paying 50,000 euros every month or every year. So for example, I just invested 50,000 euros today in on April 22nd, 2026, and in April, on April 22nd in 2036, after 10 years, I'll go back and I'll check how much my money has grown. And what is my interest rate? My interest rate is 5.2 percentage, right? And after 10 years, I would like to see that. So to find the future value in this case, or VN in this case, the formula would be P, the principal amount, into E to the raised power R and T, right? So this would be the formula. So my R here is 5.2 percentage. We'll convert it 0.52. Here you don't need to convert it onto the monthly basis, because it's a continuous and time period is equals to 10. So you don't need to convert this rate into monthly or yearly basis. The E would handle it on its own. You don't have to do any conversion here. So you plug in the values and you'll get the answer. That's it. Nothing else. And let's see the B part. I hope the A part is clear. Now let's go to the B part. If the repayments on a mortgage of 3,50,000 at 4.8 percentage per annum compounded monthly are, how long would it take to pay off the mortgage? That's pretty much simple. Like we just solved a couple of such questions. And I would like to touch upon on a different idea in this session, in this recording. So in B part, my again, it's a problem of loan and mortgages. So I'll referring to the present value form. There's a purpose why I'm writing these formulas again and again, because I want it to be internalized in, I want to make sure that these formulas are internalized. My V naught is because I need to find how long would it take to pay off the mortgage, right? So I'm more interested in N, in finding N. I know the present value, like the value that I'm getting today, which is the loan, which is 3,50,000 euros. I also know that I would be paying every month 1,750 euros per month on a monthly basis, and the compounding is being done on monthly basis. My yearly rate is 4.8 percentage, and if I try to get rid of this percentage sign, I would get 0.048. And for monthly basis, I can simply divide it by 12. So I'll get my answer. So if I divide 0.048, I'll get 0.004. Right. So this is my rate for the monthly basis. Now I can like simply plug in the values and I can calculate uh, the the period. So my V8 is 3,50,000 equals to A naught would be 1,750. 1 minus 1 plus 0.004 would be 1.004 to the raised power minus n divided by 0.004. So now here, the 0.004 is getting divided. If I take it to the left side, it'll get multiplied. And if you multiply this, what would you get? If you multiply 3,50,000 multiplied by 0.004, you're getting 1,400. You're getting 1,400. If you divide this 1,400 by 1,750, so because if I multiply this 3,50,000 euros with 0.004, I'm getting 1,400, and 1,750 is getting multiplied on the right side. If I take it to the left side, it'll get divided. So this would become 0.8, 1 minus 1.04 n. And if I, so here it's a positive one. So if I take it to the left side, 0.8 minus 1. So minus 1.004 to the raised power minus n. So I'll get negative zero point 0.2 on the left side of the equation, and on the right side, I'm getting negative 1.004 to the raised power minus n. This negative sign would get cancelled out. So I'm getting this one. So now you can take the logs. So I'll again, I would like to revise this. So I can take the natural log on both sides because I need the value for the n on both sides. So if I take the natural log on both sides, ln of 0.2 would be equals to minus ln of 1.004, right? So my n would be ln zero point 0.2 divided by, it would be negative 1.004. So you will get the value for the n if you just do the calculation on your calculator. Simple. Right? So you would get the time period in which you would be able to pay back your loan of 3,50,000. Now I'll like quickly touch upon the C part, which is a like little different concept here. If the average cost function of a good is given, find an expression for the marginal cost. What do we mean by marginal cost? Marginal cost means how much it cost us to produce one extra cost of producing one more unit, right? So the margin, what do we mean by marginal revenue, marginal cost? The cost of producing one more unit. And like, there's a whole economic interpretation of this. I mean, this apparently this seems very simple, but this is not as simple as it appears, right? It's a whole new idea, but I think there's no need to get into the details. And I need to find the marginal cost. I'm given the average cost, right? So the marginal cost is basically the derivative of your total cost. Derivative of your total cost, right? So I need my total cost function. In order to find the expression for the marginal cost, I need the equation for the total cost. And what I'm given the average cost expression. So how would I find the average value? How would I find the average cost? The total cost divided by the quantity that I produced. In this way, I would get the average cost. So for example, my total cost was 100 rupees, 100 euros for producing 5 goods. So if I divide 100, my total cost upon the number of quantities that I produced, that would get me 20, and 20 is my average cost for producing each unit, right? So this is how it looks like. So if I were to find the total cost formula, the total cost would be equals to the average cost multiply with the Q, right? So if I multiply 20 by 50, I'll get 100. So 100 is my total cost again, right? So there's a little example that I gave in the circle for your understanding. But here I'm not dealing with the numbers. I have expression. Now, in order, I'm given with the average cost formula to find the total cost. I can multiply the average cost formula with the Q, the average cost expression with the Q. So what would happen? I have the expression for the average cost, and that is 2Q plus 13 upon Q plus 6 multiply with the Q. So the expression for the total cost would be 2Q square plus 13Q or 13 because this Q would get cancelled out with this one, and plus 6Q. Like this Q would get multiplied with the first term, with the second term, and with the third term separately. So this would be your expression for the total cost. Now, marginal cost, I told you this is the derivative of total cost with respect to Q. So marginal cost is technically the derivative of total cost with respect to quantity. So you would simply take the derivative of this equation, right? So if you take the derivative of this equation, that would be, what would be the derivative of 2q square? The 2 into 2q, 2 minus 1. Power rule simple. The derivative of a constant is always 0. So the derivative of 13 would be 0. Plus 6q, it would be 6, just 6, right? So you would get 4q plus 6. So this is the expression for the marginal cost. I hope it helps. Thank you so much.